Hi, everyone. Welcome.
Welcome to another science video with Marty and James, or James and Marty.
Whichever way you prefer, they're both correct.
Yes.
Yes.
And we'd like to invite you to send your comments in on the Q&A box as usual. And today we're going to talk about oceans. That's that blue stuff in the back. Right. That's the Mediterranean, did you say, James? Is that the Mediterranean?
I'm pretty positive that's the Mediterranean.
Yeah.
And the video that plays behind us is a loop of a minute or two. And in a moment, it'll loop back and you can see part of the Atlantic as well, where the Atlantic meets the Mediterranean Sea.
Okay, so we're going to talk about oceans today. And I thought it was kind of peculiar that the name of our planet is Earth, considering that over 70% of the Earth's surface is covered by the wet blue stuff.
So you think our planet should be called water?
I was going for something a little more poetic. Oceania.
Oh, that sounds much better.
Doesn't that?
Yeah.
That's better than water. It's the planet Oceania. And scientists believe that life started not on land, but in the ocean. Now, scientists just have discovered a fossil that was about 4.4 billion years old.
That's old.
And I'll show you what a fossil is. I have a couple of fossils here. There are basically two kinds of fossils. There's this. This is, you can see the...
It looks like a shell.
A shell, right. It's like a footprint of a shell, if a shell had a foot. Anyway, you had to be there. Anyway, there's the shell, and it got in this soft rock, and then or soft mud, and then the mud hardened. And so this is called a trace fossil because you could see the imprint of it. It's not the actual shell. It's just like if you leave a footprint in mud on a muddy day, and then it dries up and you have a hardened footprint. The other kind of fossil is called petrified, and petrified means turned to stone. So here in the middle of this hunk of rock, you can see this critter.
Actually, if you pull it back towards us a little bit, it'll be a little bit more in focus. There we go. Yeah.
Is that better?
Yep.
And so there's this critter in the middle of that right there. And yeah, that's that circular kind of guy. And that's this, a fossil. It's petrified. This is turned to stone. This is no longer that material that the critter was made out of. Anyway, scientists...
We have a few suggestions for other names for our planet on here.
Okay, I'm ready.
Isis suggests that we call it aquatic.
Aquatic.
I like that.
Yeah.
Lorna says oceano. One of those.
Yeah.
Ocean, and then with an O at the end.
I like Oceania better so far, but I'm willing to. I'm willing to.
Oh yeah. And Sarah says Aqualand.
Is that where Aquaman lives?
Yes.
Aqualand.
Yes.
Anyway, 500 million years ago, there was no life on land. No animals, no flowers, no insects, nothing. It was all in the water. Now, when I went to high school 7 years ago, I was taught that, well, there was gases in the air and lightning, and that's what created the first life. Did you learn that?
Something similar. Yeah.
Well, it turns out that's not what scientists believe today. You know, science is not a static field. And what I mean by that, it's not an area where things are written and nothing changes, because things change in science. People have different viewpoints or make new discoveries, and so they have to change things around a little so that it fits these new discoveries. And this is one of them. So originally, we thought that, well, it's the lightning and the gases and the whatever, and that created amino acids, which make protein, which make bodies, and that's how it happened. That's what I was taught. But about 40 years ago, some scientists did some other research, and there are these things called hydrothermal vents in the bottom of the ocean. So hydro is water, and thermal is heat. And
Okay. Should I pop over to our slides here?
Not just yet.
Not yet. Okay.
And these areas of the oceans are heated by melted rock, and they melt the rock and they go and they take this cold, well, the ocean water at the very bottom is very cold, but then this hot water comes up and there's this little area where it's warm, not cold, not boiling hot, but warm. And there are minerals from the rocks that melted, and that can be an area that scientists believe supported life at first. So let's take a look at the first one. So the first slide. So,
the first slide. If you miss any part of this, or you want to go back and hear something that Marty said again, or you want to catch any of our earlier 200 webinars.
Wow.
Yeah, 200 plus. You can go to youtube.com/the Delphian School. Every webinar that we've done is recorded and up there for your reviewing availability.
And pleasure.
Yes.
And edumacation. That too.
Yes.
So
there's some really great writing and grammar webinars that
could help me.
too.
Okay. So,
here we go.
So this is this shows you you might have seen this before, the plates. We talked about the plates, tectonic plates, and how when they separate, it leaves an area where the hot melted rock can come up, and that's what forms from the spreading center in that picture. So that's where there could be these hydrothermal vents. And there's another one. Let's take a look at the next picture.
Good. Hydro meaning water, thermal meaning heat. Yeah. So water and heat. Yeah.
Yeah, that's what I said.
Yeah.
Earlier. And you
I'll tell you what was happening. As soon as you said that, I'm like, oh, he did say that. He said exactly that, didn't he? I was reading the comments and you were talking, and I wasn't listening to you.
You're hereby forgiven.
So what I'm saying is, if I miss any of today's webinar,
you could watch it again at that website.
Back and I can catch it.
There's the web. Yeah, there it is.
I can see where Marty said the thing.
Okay.
Good.
Now here's another picture. This is a new model. What happens is you have these cracks and you have hot magma or hot rocks, melted rocks coming up, and they can hit the bottom of the ocean. And that's where you see on the number 4 there, these on the right side, these hydrothermal, and what does that mean again, James?
It has to do, hydro's having to do with water and thermal is having to do with heat.
That's still correct. These hydrothermal vents. And so let's take a look at the next picture. I think we have another picture of
wow.
Now there are 2 kinds of hydrothermal vents. One is called the black and the white. So there's a black hydrothermal vent and a white hydrothermal vent. And it depends on what kind of rocks are being melted. But there's lots of nutrients there. Nutrients are foods and things that bodies need to grow. And so there's lots of things there that can start supporting life. Okay, now, where did life begin? Let's take a look at the next picture.
Okay, good.
It says, land is unlikely. There was no oxygen. There was no ozone layer to protect any creatures that might have been on land. And ultraviolet light from the sun destroys the bonds that we needed. It was only until later when we got an ozone layer that protected us, protected land creatures, that life could begin on land. So shallow pools, that's what they once thought. Shallow pools, lightning, nope. Now they think it's these deep sea vents because we have DNA evidence. So DNA is the stuff that is in every body cell for every kind of creature that tells it what kind of body to build. So science is an ever-changing field. Less than 5% of the planet's oceans have been explored. Isn't that amazing?
That's amazing. That's still amazing to me. I know that, and I knew that, and I hear it, and it still fascinates me.
I mean, what kind of creatures are out there? What kind of amazing things are out there that we don't know? And we're not talking about Mars or Jupiter. We're talking about Oceania.
Yeah. I mean, I've been talking for, in space webinars for the last 2 months about, let's go find planets outside our solar system and explore Mars and the moons of Jupiter, and less than 5% of our very own oceans have been explored.
We don't know
There's so much
we don't know what's there
to see in there. I know that there's all those old sailors' stories of these giant sea monsters that would eat boats and stuff like that. And we used to think that they were all just made up tales. And then there's every once in a while, someone will get some footage of one of these giant squids that
could be.
We barely have ever seen, but we know that they exist.
Right.
They're huge.
Okay, so the world's longest mountain chain is in South America. Let's take a look at that. There it is, all along the west coast of South America. Those are the Andes Mountains, and they go for 4,300 miles or so, okay? And that's quite a bit, 4,300 miles. That's wider, that's like 1.5 times as wide as the US.
Yeah.
Yeah.
New York to LA twice.
Well, 1.5 times.
New York to LA and mostly back to New York.
Fine. So that's not Earth's longest mountain chain, though. Longest mountain chain is the mid-oceanic ridges. Look at that. That is one mountain chain, and that stretches over 40,000 miles. That's 9 times as long as the Andes Mountains.
Wow.
So this is caused, again, by the plates. This is where there's the edges of the plates, and the plates can move apart. And when they do, hot rock comes up, hits the cold ocean, and forms a hill. And then more of it spreads out, and you get a bigger hill. And these are the mountains, because this has been going on for gazillions of years. Yeah. Okay. Now, here's an interesting fact. There are more ancient objects under the sea than in all the museums in the world. How could this be? Why are there more ancient artifacts, they call it? That's objects.
Like human objects? Like things that people made, and then
things that people made, statues and things like that. There's more under the sea than in all the museums. And how come? What do you suppose that is?
Let's see. I think Lorna's got it. Lots of shipwrecks, she says.
Lots of shipwrecks.
Lots.
Ding, ding, ding. That's right. There have been over 3 million shipwrecks. And let's take a look at one of them.
Okay.
Okay.
Wow.
So there's this shipwreck. And so you could have ships that fall to the bottom of the ocean because of bad weather, or they hit some rocks that, that were near the surface, or it could have been one of them sea monsters.
Yeah, I was just going to say attacked by a giant sea monster. You can see the tentacle marks right there. I'm joking. Think so. That's no.
Okay. Well, we have oxygen on this planet thanks to plants, right?
Thank you, plants.
I know. If it wasn't for plants,
we would be here.
That's right. We would have run out of oxygen long before man appeared on the planet. So it's thanks to plants that are doing this process called photosynthesis. And what that word means is photo is light and synthesis means change. So it's light energy changing carbon dioxide and water into oxygen and food.
And if you missed that, don't worry. I'm probably going to repeat what he said in about 2 minutes.
2 minutes. Okay. Anyway.
Good. Oh, Lorna's asking, is this near a hydrothermal vent? No, this is not near a hydrothermal vent. This is much closer to the surface of the ocean. This is much closer to land.
Right.
You can see that there's sunlight coming in and actually giving light to this, which shows that it's very close to the surface. Those hydrothermal vents are very, very deep in the ocean, miles down sometimes.
Right.
Okay.
And so, do you think we're talking about photosynthesis, making oxygen. So I always learned, it's trees and plants and bushes that give us that. Nope, not right. Between 70 and 80% of the oxygen produced by plants are produced by in the ocean by little tiny creatures called photoplankton. That's the name of them. I have a picture of photoplankton. So these little microscopic guys here.
Look at those little oxygen machines.
They are. Well, they're green.
Yeah.
Green indicates they take food, they take carbon dioxide and water in and make food and oxygen. That's what these guys are doing.
Thanks, guys. Good job.
Yeah. Now, the Pacific Ocean is Oceania's largest ocean. There are others, but the Pacific is larger. And, and James is jumping ahead. There are 25,000 islands, I counted them last night, in the Pacific Ocean. Let's take a look at this map.
Wow.
There are whole bunches of islands, and you can see some of them here, but
it's just incredible to me.
It's incredible.
Yeah.
It is.
Nature is amazing. And if anyone here has watched Moana, this is the region that's taking place. And not only are there islands dotted all throughout there, and not only have there been millions of shipwrecks in human history, but we keep getting on boats. We keep going out. We keep exploring.
Yeah, man wants to explore and find out about the unknown. As a matter of fact, I remember when I was a kid, I read this book, Kon-Tiki. Did you ever read that book?
No, I didn't.
It's about this guy who thinks that a lot of these islands were populated by people from South America. And so he built this raft out of balsa wood. There are lots of balsa trees in Peru. And
it's a very light, strong wood.
Yeah. And so he took these things and made rafts out of them and sailed using just ocean currents and maybe a little sail. He went all the way and landed on some of these islands. I thought that was pretty interesting.
That's a nice way to, you have a theory.
And he went out and he proved it.
And you go and you test it.
Right.
Yeah. Conclusion. I got there.
Now we're going to talk about another feature of the ocean called rogue waves.
Oh, I love this topic. I want to rewind really quick. Lily's asking, what's Oceania? Remember at the start of this webinar, we said, we call our planet Earth, but 70% of it's covered in water. So we should maybe call it Oceania or something like that.
Yeah, we're sticking with that.
So if you hear him say Oceania, he means the planet formerly known as Earth.
That's right.
Yeah.
Anyway, there are these things called, whoa, look at that.
That's a big wave.
Rogue waves are unusually large and unexpected and suddenly appearing waves that could happen at sea, like this. That's extremely dangerous to a cargo ship or an ocean liner. Mm-hmm. I don't know if you've ever seen the Poseidon Adventure.
Yeah, actually I have. I was about to say, I don't know if you've ever seen Poseidon. But it's a cruise ship and a rogue wave comes along and, disaster happens.
Anyway, there are about 10 rogue waves every year that are 82 feet high or higher.
Mm-hmm. That they've recorded. Yeah.
This could ruin your whole day if you're on this ship and an 82-foot wave comes along or higher. Mm-hmm. And these things don't only happen on the ocean, they also happen on beaches. And what happens is you could just have this mix of waves, and all of a sudden the high part of this wave meets the high part of this wave, meets the high part of this wave, and you have a wave this high.
And it's just the right combination at the wrong time.
And then it disappears just as quickly as it appeared. Yeah. After a few seconds. The next slide
we had a few people jump in the Q&A section and say tsunami. This is different. This is different from a tsunami.
Well, tsunami does cause large waves.
Yes.
But this is not what that is.
Yes. This is, it can be similar, but it's actually pretty different in how it's happening. A tsunami is when the whole level of the ocean rises for a little bit. This is just one little bit where it just goes bloop, rogue wave. And then
it disappears. And tsunamis usually are not that high on the ocean. It's when they get to shallow land, to shallower water, where they get very high.
That's
Let's
right.
take a look at this next picture.
Yes.
This
There we go.
is a rogue wave. Now, every year I read about people at the beach and, you know, they're posing and saying, hi, take a picture, and they're gone. You know, this all of a sudden, this rogue wave comes in and sucks them out to sea, and you never hear about them again.
So when you're at the sea, just don't turn your back on the ocean for too long.
Oh, yeah.
Yeah.
So it could be caused by high winds and strong currents and that sort of thing. And this, I thought it's really interesting.
I do have one thing to add to the rogue waves bit. I was reading about this just a couple of weeks ago.
Really?
I didn't know you were going to talk about this today. And as soon as you said it, I'm like, yay, good.
Okay.
And again, we're going to go back to old sailors' tales of sailors telling stories. This huge wave, 100 feet high, came and, you know, swamped the ship. And, you know, they found this guy on a beach later on, and they're like, okay, he's crazy. He's you know, it was a 20-foot wave, but in his mind, it was huge. As they started building more like oil drilling platforms around the world and stuff like that, and they have instruments on those to measure the waves and stuff like that, they started getting every once in a while, just out of nowhere, they would get readings of, like you said, 10 waves of 82 feet or higher every year. They started actually being able to record these. Several instances of waves over 100 feet.
Wow.
When the current ocean conditions should not have supported that at all. And it's happened too often for them to think that it's just a mistake in the data anymore. So our amazing planet.
Oceania. So scientists that study the ocean are called oceanographers. They are like graphing or drawing what the ocean, especially the ocean bottom, looks like. But they don't really have detailed maps of the ocean body, or the ocean floor. They have some idea of what's on some of the ocean floor, but not a lot. As a matter of fact, we have more details, yes, of Mars than we have of our own ocean floor.
Yeah.
I think that's incredible.
It's pretty amazing.
We have instruments that can go and look at the ocean floor and map it, but you're only looking at this little narrow bit of ocean when you do that. And so look how long it took to find the Titanic.
Yeah.
It took years to find of searching, and they had a general idea of where the Titanic was. Or the Bismarck. The Bismarck was a German ship in World War II, a battleship. And so we know about where it got sunk, but it took a lot of exploring to find out, because the ocean is very vast. And when you're just having a ship go by, even with some sensor, you're just getting a little strip of it. And what about that flight? What was it, 371?
Yeah.
That we don't, it's in the ocean somewhere, but because the ocean is so vast, and once you get down a little ways under the water, you can't see a heck of a lot.
Nope.
That was years ago, that flight. And we still have no idea where it landed and what happened. And
we may never, because anything that goes into the ocean is going to get even metal. You know, the Titanic won't be recognizable as a ship in the next 100 years or so. There's microbes in there that are eating away at the metal. Makes a good snack.
Okay.
Yeah. We do have a question here from Anjali. Does another planet have an ocean? I don't know about another planet, because long conversation on that, but there's several moons in our solar system that we know have oceans under the surface, liquid oceans under the surface.
Right. They're so cold that there's ice on the outside.
It's like a shell of ice almost a mile thick on some.
Wow, that's a pretty big shell.
But there's 2 moons that they know have more water on those moons than we have on Earth.
And what moons might those be?
That is Europa and Enceladus.
Okay. And so we know that because we've had satellites fly by and they take a picture, and we see these places where there's water coming up and spurting up into the atmosphere. and we've tested it, and we know it's water coming out. I don't know if it's salt water, probably, but it's so we know that there are other planets, and where there's water, there's a possibility of life. And it could be on these other planets. We're getting a little off the subject of Oceania here, but it's interesting.
Well, you sit down with me, we're going to talk about space.
And you find out that there's these pressures from these moons of Jupiter, because Jupiter is pulling them one way, and so then they spin around and Jupiter's pulling them the other way. And so this motion is creating heat. And not only that, there's the pressure which of the moon itself, which makes things warmer. And so they have warm inside, so that ice on the outside could melt. You know, water is a pretty common ingredient in the solar system.
Yes.
Comets have water, and planets, we know Mars once had water. It lost its atmosphere. And
Mars, we know that Mars once had liquid water.
Right,
They scraped the surface and they found ice water. They found water ice right under the surface. Not on the surface, because that all got
evaporated away.
Kanan's suggesting that people use underwater metal detectors. He's asking have those ever been used before? Yes. But again, the problem is you can only look at a little bit at a time. So if you know, like, the ship went down here, let's go scan this area with the metal detector.
Right, but then it's like you have to crisscross, you know, a little lower.
Yep, you just got to have really good concentration and patience in order to find anything down there.
Right, right. But some people do and some people have.
Yeah.
Talk about finding things in the ocean. I was researching the other day, and I came across this fact, which I thought was startling. There are, in the ocean, 20 million tons of gold.
That's a ton of gold.
That's 20 million tons.
That's what I meant.
Okay, that's a lot of gold. So what's the problem? Gold is worth a lot of money. The problem is some of it is dissolved in the seawater, so it's just a teeny tiny bit, and some of it is hard to get at. Maybe it's in an area that's really deep or that sort of thing. But 20 million tons. 20 million tons.
20 million. That means that we can make a lot of movies and TV shows and video games where the plot is finding gold lost in the ocean.
That's 400 billion pounds. And
yes,
of this stuff.
That would be amazing.
400 billion pounds.
Do you know how many cheeseburgers I could buy with that?
Do you know how many teeth you could fill with that?
I'm going to need those teeth after I eat all those cheeseburgers.
Eat those cheeseburgers. Okay.
Okay, we have a burning question from Shanna. If they ever found Amelia Earhart's plane, which went down in the Pacific Ocean, and they knew about where she was, about where they should have expected to find her, researchers they think with maybe like 80% certainty that they found her plane just off the coast of a small island in the South Pacific. They can't be 100% positive. They'll never be 100% positive, but it's the right kind of plane. It's in the right spot. They know that it crashed at about the time that her plane crashed. So they're pretty certain that that was it. Yeah.
Okay. Thank you. So as long as we're talking about celestial objects in the sky, did you know that the Pacific Ocean is wider than the moon?
Marty, I didn't know that, actually.
You didn't.
I did not know that.
At its widest point, from Indonesia to Colombia, the Pacific Ocean is 5 times wider than the moon.
Wow.
And there's a reason for this. Scientists believe that in the early days of the solar system, before there was any life on the planet, when there were still lots of little planetoids or little planets floating around.
Oh, it was chaos.
It was chaos. And so they think this is what happened. This big chunk of, well, to show it like that with the Earth already, like that's not true. But this big chunk of rock came in and hit the Earth right in the Pacific Ocean. And then that threw out a lot of material, which gravity pulled together and is now our moon. But that's why this was 4.5 billion years ago.
It's a safe time ago. Yep.
And it's a Mars-sized rock hit the Earth, and that's why the Pacific Ocean is so big, because it was formed by this impact.
That would explain it. And they're pretty positive that the moon is made out of the debris of a collision, much like that, because they've tested rocks on Earth. They know exactly what they look like. They've tested rocks from the moon. They know exactly what those look like. And they looked far too similar for another explanation to make more sense than that.
Right. So if you want to know why the Pacific Ocean is the largest ocean and why it's 5 times wider than the moon, there's your picture. Okay. Jumping ahead.
Yes.
So, do you know, I read that some countries in the Middle East, which get very, very little rain, like 4 inches of rain a year, that's not going to cut it.
No.
What they want to do is they want to try and figure out how to get an iceberg from like Antarctica and tow it on a boat. Or
you might go to this next
with
graphic
a boat.
here.
Yeah, let's go to
Okay.
the next graphic.
There we go.
So that's what they want to do. They want to get a big boat and somehow tow this iceberg to the Middle East, and where it can provide 40 billion gallons of water. That's enough for 1 million people to have enough water for 5 years.
Wow. And you know that those icebergs, that's gonna be fresh water.
That is fresh water.
Yeah, that's not salt water, people.
No, it's ice. Ice is just fresh water, and so that's what they want to do. They've actually tried it in where you can see Cape Town. Cape Town is at the tip of Africa, and so what they want, they've already tried this, and I think they want to get these boats. I don't know exactly what happened, but that was what the first thing they wanted to do, is get these icebergs and bring it to Cape Town. And then somebody in the Middle East said, hey, if that works, let's try it for the Middle East.
Yeah. It's worth a shot. It's worth a try.
Yeah. So let's take a look at the next picture and we'll get an idea of how big these icebergs. Whoa, look at that.
That is massive.
So when you see an iceberg, just realize it's like an ice cube. If you have an ice cube in water, there's just a little bit sticking out from the water. Most of the ice cube is under the water. It's the same thing with icebergs. You see a little bit of it. Oh, it doesn't look very big. Well, look below the water. It is humongous.
Yep. The Titanic learned that.
That's right.
Yes.
Anyway, we're going to talk next about the Mariana Trench. There is the location of the Mariana Trench. It's located between China and Australia, or I guess it's north of Indonesia, between Indonesia and Japan, whatever you want to call that area. That's where the Mariana Trench is. And it's famous for being the lowest point on Earth. In other words, you can go down and down almost 7 miles below the surface of the water before you hit the land that's at the bottom of that little bit of ocean. And more people have been to the moon than have been to the Mariana Trench. Yep. Why do you suppose that is? I mean, why, hey, I'm going on vacation, I'm going to go to the Mariana Trench. Why do you suppose people don't do that?
Let's see, AG says pressure, ISIS, yeah.
Exactly.
Okay, a ton of people are saying the water pressure is too deep.
Right, the water pressure would crush you like an elephant sitting on an egg. I mean, it would just be crushing, tremendous pressure because of the weight of all that water.
Yeah.
Do you know the weight of the air, just a column of air from the atmosphere, about a square inch of air is almost 15 pounds on every square inch of your body.
Yeah.
Could you imagine 7 miles of water and what that weight would be on your body? It would be a tremendous amount of weight that would crush your body Anyway.
Aren't you glad that you tuned in? But the good thing is they have really strong submersibles, these boats that can go deep underwater and that can handle that pressure for short periods of time.
Right.
It's easier to go into outer space where there is
No
pressure.
air and no water, and it's hard to get to.
But it's easier than going down 7 miles. It's easier to go up, 238,000 miles.
Right.
That's incredible.
Okay.
Okay.
Next, we're going to talk about our old friend, the Mediterranean Sea. Ta-da! So the Mediterranean Sea used to be dry. That area here, we're between Spain.
We're rotating past
it.
It'll come back in a minute.
Okay.
Yeah.
There's that area. Some 5 million years ago, scientists have done studies, and they found that the area was dry. And there are lots of theories. When scientists don't know the answer, they develop theories or develop names for things. That's the Mediterranean. That was all this dry land once upon a time. It's like dark matter and dark energy. Scientists don't know what it is. There's something out there, and that's expanding the universe, and scientists don't know what it is, so they say, let's give it a name. They could have called it Fred. Instead, they called it dark energy that's pulling the universe apart faster. And the same thing with gravity. There's this gravity, and scientists don't know where it's coming from. So rather than calling it, they call it dark, dark energy and dark matter. They call it dark matter because they can't see it, they can't detect it, and it has a nicer ring than
I'm going to call it from here on out. Yeah. And over here we have
Yeah. Good. So one theory as to what happened with the Mediterranean and how it got filled up with water is some scientists think that that little space there
between
Africa and Europe just got a little bit wider to let water in. Other scientists say, well, what happened is a comet might have hit the Earth and melted a lot of the ice, and that made the sea level rise, and that filled it in. We don't really know.
Both of those would explain it.
It would.
Yeah.
But that's the thing I want to emphasize, that scientists don't have all the answers. There's lots and lots of unexplained phenomena, unexplained events that scientists have a theory about, but nobody's really sure. And so if you're interested in some aspect of science, whether it's medicine or biology or oceanography, learning about the ocean, or marine biology, studying animals that are in the oceans, it's a fantastic opportunity for you to find out and add to the amount of knowledge that we have. Okay.
That's right.
Now we're going to jump right to the volcanic activity of the Earth. There is an area in the South Pacific, there's the Pacific again, that's no bigger than the size of New York State, if you know how big that is. And this area of the South Pacific contains 1,133 what?
Waters. Okay, that's probably not the right answer.
Probably not the right answer, but it's probably what we have on the screen here.
Volcanoes. There we go. I knew
right.
you guys would get it.
And the largest volcano is Mauna Loa. That's the name of the volcano. It's actually the largest volcano on Earth.
Wow.
The reason it's not as high as other volcanoes is because it starts at the bottom of the ocean. And it built up and up and up, and it lets out lava like this. Remember, we talked about volcanoes, and some of them kick out dust and ash and that sort of thing, gases that can knock trees down, knock a forest down for miles.
Yeah.
And that's this is the type of volcano that just melts the rock, and the melted rock called lava comes out. And I think that actually Hawaiians have 3 or 4 different names for different kinds of lava.
Interesting.
Yeah,
I mean,
it's like
that would make
Eskimo.
sense.
Yeah.
They're experts on it.
It's like Eskimos have, you know, dozens of different names for snow. Did you ever hear that?
No. I don't.
Eskimos have different. Well, then I'll say it again. Eskimos have lots of different names for snow. Yeah, there's like a powdery snow, and I know packing snow, and wet snow, and dry snow. They have different names for lots of different kinds of snow.
That makes sense. Like here in Oregon, we have lots of different kinds of names to describe the rain.
That's right.
You know, that's what we're subject to. Like, is it a sprinkle? Is it a drizzle? Is it real rain? Is it
a mist? Is it a shower?
Yeah.
Yeah.
Okay, that makes sense. Yep.
Anyway, this volcano, Mauna Loa, measures more than 10 miles high from the ocean floor to where it is now, Hawaii.
Wow.
Isn't that amazing?
I love our planet. I love nature.
Yeah. And so, because so little is known about the ocean, it's estimated, I read about this I found really interesting, that there's more than 90 different kinds of animals that are in the ocean. I'm sorry, 90% of the animals that are in the ocean, no, we have no idea about, because so much of it is unexplored. I know they have all these different kinds of animals, and every once in a while something washes up on the beach and a scientist finds it and says, what the heck is this? And then they name it after the guy who found it. And so there's so much in the sea, and so much that unexplored in the sea, especially the lower down you go, that we don't know what's there. It's just there waiting to be discovered, waiting to be cataloged. I have some pictures here of some things that have been found in the sea.
These look like aliens.
Yeah, they do. I mean, look at some of them. They're really strange. And so some of them look more like plants than animals.
A lot of them look really surprised that their picture's getting taken.
Yeah, like the guy in the upper left.
Yeah. Wait, huh? What are you doing here?
Okay. So here's another thing. Oceans are not just big bodies of water, or more correctly, salt water. They have rivers flowing through them, or not rivers of fresh water, but currents. So what happens is you can have this area that gets warm water, like the Gulf of Mexico, and then you have the Gulf Stream. And the Gulf Stream goes all the way, you know, the Gulf Stream helps Europe have milder winters. And so you have this stream of water, this river of water that's underneath the surface, and it's on top of the surface too. And so it's circulating around, and it's a current, it's a river of water in the ocean. Then you have the Labrador current coming down from between Canada and Greenland.
That's gonna be real cold.
You have they call it here the California current. I've also heard it called the Japanese current. It starts in Japan, comes up and around, goes south, goes to Alaska, and comes back down. So you have all of these rivers of different waters. And so you could have this fish that's native, that's normally found in the Gulf of Mexico. All of a sudden, it's found off the coast of Ireland, or
France.
Yeah. So it's because of these currents of water that happen underneath the oceans.
All right. Yes, astute viewers, we are out of time. We just love talking to you. We probably have one more slide to go.
One more slide to go.
Good. Just give us another minute. We'll wrap up here.
Okay. I thought this was really interesting.
Okay.
Every year, shipping containers get lost. Either they're on a boat and the boat starts rocking and one goes overboard, or the ship goes down and the shipping containers are lost. Well, in 1966, The United States lost a hydrogen bomb at sea. I knew I had it around here somewhere.
Did you have the hydrogen bomb?
I thought I gave it to you.
I thought you had the bomb.
So here's a picture of this bomb. And this was aboard a airplane. And the airplane was having difficulty and crashed. And for a while, we lost it. Oops. The good news is we found it, or somebody found it, with the help of sailors, or some Italian sailors, I think it was. The US government relocated their bomb, which is now safely, I don't know where.
Yeah, that bomb is probably never going to cross the ocean again.
Neither is the plane that was carrying it.
No.
Or the pilots from that plane.
Oh, no, yeah.
Anyway, thanks for watching again. It's been a pleasure helping you learn and helping us learn, because we find out, just in researching about this stuff, we find out stuff that we don't know. So I urge you to be curious. Curiosity is the cure for boredom. If you're feeling bored, find something to be curious about. Whatever it is, whether it's art, or whether it's painting, or whether it's space, or whether it's Oceania, or whatever. If, find something to be interested in, and your boredom will be gone like that.
Take it from him, the least bored guy I have ever met.
So until next time, this is Marty and James and Marty signing off, and have a great day. We'll see you again.
Before I cut the feed here, I just want to make one final mention of the final webinar that is happening at the end of this week. It's going to be Friday, 2:30 to 3:15 Pacific time.
Okay.
Pacific, call that because we're near the Pacific Ocean.
Right.
Anyway, we've got some special surprises and thank yous and just messages to give to you guys. So everyone watching here, please definitely tune in to that. It's going to be quite a treat for us, and I hope for you as well.
Is that going to be on our Facebook website also?
It's going to be on one of these regularly scheduled webinars here. And then it will be on YouTube after that, but it's not the same as getting to see it as it happens.
Live and in person.
Yeah, you never know what's going to go wrong.
Yes, we
go
don't.
right.
Okay, right. Have a great day. See you next time.
Bye, everyone.
Bye for now.